So this is the credit recovery final exam review. Going to start right here. Choose which properties apply to each quadrilateral. I'll choose all that apply. So when we're looking at a rectangle, we want to look at each of these. Adjacent sides are perpendicular. So adjacent means next to. So I'm going to write that right here. That means next to. Right next to, right? And then perpendicular means there's 90-degree angles, okay? So what does that, is that true of a rectangle? You know what, let's just go down through these. It's true of a rectangle and a square, right? Okay, so we're going to mark that. All sides are congruent. That would be a square and a rhombus, right? So this would be B and rhombus would be B. Then it says diagonals are perpendicular. So again, what does that mean? That means 90 degrees. So that's true of a rhombus, which means it's also true of a square. So it's true of a rhombus, and a square is a rhombus. So we're going to put it up there as well. Then it says diagonals have the midpoint. That's true of all parallelograms, okay? So diagonals have the same midpoint. So that's going to be D and D and D and D, because remember, all these shapes are parallelograms, right? Okay. Then it says diagonals are congruent. This one is true of a rectangle. Again, that means they're the same length. The word congruence there, that means they're the same length, okay? So that's true of a rectangle, and a rectangle, a square is a rectangle, right? Because it's got 4 right angles, and that's the definition of a rectangle. And then opposite sides are parallel and congruent. Again, that's true of parallelograms, so that's true of all of them, right? So because they're all parallelograms. So this would apply to F and F and F. Okay, now it says, how do you determine if sides and diagonals are parallel? Okay, so when we answer this question, we got to find the slope, right? So don't we determine this with the slope? Okay, so I'm going to write, actually, I'm going to write right here, slope. Maybe my pen will work. I'm going to look at the slopes. And how do we find the slopes? We do the rise over the run. So we're going to pick a set of points over here. I'm just going to put them over here so we can practice this, okay? You guys don't have this grid on your paper, but you guys do need to practice this. So let's just pick a point over here, and let's do this point. We're going to make it A, and that would be -4, 2, right? -4, comma 2, okay? And then let's pick another point over here, and let's just call this one B. And this is the point 2, comma -2. So now we're going to connect those points with a straight line. Recall again that when a line falls from left to right, it's got a negative slope. So we know this is going to be a negative slope because A, when I move from A to B, it falls, okay? So we're going to count 1, 2, 3, 4 down. So that would be a -4. And then over 1, 2, 3, 4, 5, 6. So that's going to be -4 of 6, the slope of that would reduce to -2 over 3 because both are divisible by 2. So that's how we determine slope. Now, if another line has the same slope, then those lines would be parallel. Parallel means slopes are equal. Okay, now, what does the term congruent mean? It means that sides are congruent. It means sides are the same length. Sides, same length, okay? Okay, now how do we find that? We use the rise over run, okay? Original rise over run, not reduced, okay? So we're going to take the two numbers we got here, this number, -4, and this number 6, and we're going to do the rise squared plus the run squared, and then we're going to take the square root of that, and that's going to give us our length, okay? That's what length is going to be equal to, okay? So we're going to take our -4 and we're going to square it. We're going to take our 6 and we're going to square it, okay? And then we're going to take the square root of that. We're going to add them together. So that's going to be 16 plus 36. We're going to take the square root of that. That's going to be equal to, what is that, 52? Okay, so take the square root of 52, and all we have to do, we don't have to compute that, okay? All we have to do is compare that with an opposite side, because it's opposite sides that need to be congruent and parallel, right? Okay, so now this is true also of diagonals, right? So we can also find the the length of a diagonal, and if the diagonals are congruent, then we know it's a rectangle. Okay, now let's talk about perpendicular. So let's talk back about this slope that we found up here, this negative 2/3. Okay, so if we have a slope of negative 2/3 and we're looking for perpendicular, that means they're negative reciprocals of each other. That means the perpendicular slope has to be positive 3/2 because they flip. Okay, so if we were to find a slope 3/2 of this line that we're given, so let's just pick a point on it. Let's just say we'll pick point 1 right here. Okay, and if we go up 3, 1, 2, 3 and over 1, 2, now notice we have a line that is what? Perpendicular to our original line. There's a right angle right there. That's what perpendicular means. There's a right angle, okay? So again, we need to have negative reciprocal slopes if they are perpendicular. And this applies to the sides of a rectangle and a square. They should be perpendicular, right? And it should be true of the diagonals in a rhombus and a square. Because remember, again, a rhombus is a square is a rhombus, okay? So what is the perimeter of QRS if QR is blah, blah, RS is blah, blah, SQ? So what are we going to do with these? We're going to add them all together, aren't we? So the way I'm going to do that is I'm going to line things up. I'm going to write my 4x squared plus a 5x plus 12. I like to do this vertically, especially with perimeter, because I'm just adding things, okay? So I'm going to add the 2x squared minus the 3x. That was a plus up there. Minus the 7, not changing any signs because this is adding, okay? And then I'm going to add the x squared here, then minus 2x and the minus 8. Remember, again, I'm not going to change any signs of anything here because I'm adding. So 2 plus 4 is 6 plus another 1 is 7, so this is going to be 7x squared. Then we've got 5 minus 5, so this just cancels out, doesn't it? So that means I don't have an x at all. And then I'm going to do 12 minus 15, which would be minus 3. So there's my answer right there. Okay? So the next one says, Dr. Thompson wants to put a section of red carpet in a larger area of gray carpet. The sides of the gray carpet are, so we have gray carpet that has sides of 8x minus 4 and x and 10 plus 10, right? So we're going to find the area of the gray carpet first. So I'm going to find the area of the gray carpet. And I'm going to do that with our box method, okay? So we're going to find the area of the gray carpet. That's going to be 8x squared minus 4x. 8x times 10 is 80x, and then negative 4 times 10 is negative 40. Remember that in our diagonals, we should usually get our like terms, right? Y'all see that? So this is going to be 8x squared plus 76x minus 40. Then they're asking us about, it says the area she wants to put the red carpet has the sides of 4x and 2x plus 1. So red carpet is going to be 4x times our 2x plus 1. So this time I don't really need to use the box. I can just use the distributive property, right? So that's going to be 8x squared plus 4x. Now what are we going to do with these two parts? Because it says what will the area of the gray carpet be once the red carpet has been installed? So that means now there's less gray carpet, right? So we're going to take our gray carpet, 8x squared plus 76x minus 40, and we're going to subtract from it the 8x squared and the minus, whoop, went too far, the minus 4x, right? Okay, so we're going to make them both negative, then make that positive. Change the signs of both. That's really the key, okay? So now this is going to be gone, and that's going to give us, what is that? 76 minus 4 is 72x minus 40. Right? Yep, I think the answer on the key is wrong. So that's the correct answer. Okay. All right, the next one says, what's the difference between an image point and a pre-image point? Image is after the transformation. Okay. Image is after the transformation. Pre-image is before any kind of transformation, okay? That's important because sometimes things are written in words and we need to understand pre means before, right? It says, what statement can be made about two sides of a right triangle that form a right angle? So let's draw this. So we got a right triangle, right? Okay. And it's got a right angle there. This would be A, this would be B, this would be C. So what could we say about the two sides? Couldn't we say AB is perpendicular to BC? Right? Because why? Because they form that right angle. And wherever there's a right angle, sides are perpendicular. Okay? Number 7 says, what types of lines can be drawn between vertices of the preimage and the image of transformation is a translation. So these lines in a translation would be lines that are parallel and congruent. Okay? These lines are parallel and congruent. Okay? So this is the one that makes a 3D image. Now, the lines with the reflection are going to be parallel, but not congruent, okay? Not congruent. This is the one that when we bisect our parallel lines, that's where our line of reflection is, okay? And then rotation, our lines are going to cross, okay? The lines are going to cross when we have a rotation, okay? Then it says, how can you tell when a dilation has occurred? The shapes are not the same size. That's really the key, guys. Shapes are not the same size. Shapes. So you look at one side, not same size, okay? Just look at one side and compare it, okay? All right. Given the points x, -5, y, 3, -2, and -1, -4, write a rule for what changed and then state what type of transformation occurred with the points below. Okay, so we're going to look at just one point. Okay, so we're gonna focus on x here. Okay, so here's our x's. So what do you immediately notice happened? The sign of x changed. So this would be -x. Did anything change about y? Yep, the y changed as well. So this would be -x, -y. And if it's -x, -y, isn't it a 180-degree rotation? Okay. Then again, we've got this one right here and the -5, -2. So they switched. You notice that? So it's y, x. Did either one of them change signs? Nope. So it's just yx. Right? So it's 2. So this one is a reflection. Remember, if they just flip, it's a reflection over the line y equals x. Okay? Then again, we're going to look at 5, 2 now. So what changed? The sign of x, right? Because it became positive. So this is going to be -x, comma, y. So if just the x value changed signs, then this is a reflection over the x-axis, right? Remember, if the, reflection over the y-axis. Here's the deal. When the sign of x changes, it's a reflection over y. If the sign of y changes, it's a reflection over x, okay? So we're going to go back up here, and we got 2, 5 now. They flipped, right? So that's going to be y, x. Did anything change signs? Yep, that one did. So this is going to be, for D, it's a 270-degree / 90-degree clockwise rotation, right? Okay. Now we're looking at 5. Whoop, let me change my color. I'm trying to switch this off so you guys can see what I'm doing. -5, -2. Okay, so this time the y changed, right? So this is going to be x, comma, -y. That means this reflection over the x-axis, right? E, C, T. Okay, let's scroll this up a little bit. I'm going to write my point out here, -5, comma, 2, because as I scroll down, we're going to start to lose it. Okay, so then again, we're looking at this point and we're comparing it with -5, -2. So we notice immediately they flipped, right? So it's y, comma, x. And what happened to signs? The negative 5 stayed negative, right? But the 2 became negative, didn't it? So it was our y, so now that's negative, okay? So for f, this is negative yx, and so that's a 90 degree slash 270 degree rotation. Oh, wait, clockwise rotation, right? Okay, and then g, again, I can see that they flipped. So we're going to flip them first, y comma x. And what the sign of the 2 changed, right? So that's going to be negative. And the sign of the y changed because it was negative, and now, or the x now became positive, right? So this is then going to be a reflection over line y equals negative x. Because they flipped and both changed. Y equals negative x. Okay, so then it says, what's the translation vector given the point x? So this was our original x up here. Okay, so when it becomes x prime, what happened to it? So what we want to do is we want to take the ending point and subtract from it our beginning point, right? So end, it'd be great if I could write. So we're going to take our end point and we're going to subtract from it the beginning point, okay? So these are just our x values. So that would be, when we subtract the negative, it becomes positive, right? So that would mean it would be 7. Okay, so that's going to be, our vector is going to be a positive 7, right? Now let's do our y value, okay? So we're going to do the same thing here. Our new y was negative 1. And again, we're going to subtract from it our beginning point. So that's going to be a negative 3, right? So that's going to be negative 3. So that's going to be a negative 3 down there. That's our vector. So now when we write this as a rule, it's going to be x plus 7, y minus 3, right? And what is the transformation in words? So when we have a positive for the x value, it's going right 7, right? And then it's going down because that's negative 3. So that's our rule. For number 9, it says in the figure LM is parallel to L and M are parallel. So I'm going to go ahead and put some parallel symbols on these lines because that's important. It says that the measure of angle 2 is 39. So the measure of angle 2 is 39, and it says the measure of angle 12 is 53. So where's 12? 53 right there. And then it also tells me that the measure of angle 14 is 92. Looks more than 92 to me, but we're just going to put what it says because the drawing could be not the best as far as accuracy is concerned. Okay, so there we go. So now let's just go work through this drawing, okay, with what we know. So that means vertical angle up here, angle 4 is going to be 39, isn't it? Okay. This angle 16 is going to be 92 because it's a vertical angle. This angle 10 is going to be 53 because, again, it's a vertical angle to the 12, okay? So do any of those. So 53, 10. This is 53 right here. We did that. We did angle 4. That was 39. And then we did angle 16 is on here, and that's also 92. Okay, so now let's talk about some other relationships that we have. So if you look at angle 1 and 2, they form a line, right? So couldn't we, to find angle 1, couldn't we go 180 minus 39? So that's going to be equal to 141. So that means that angle right there is 141, which means its vertical angle is 141, right? Okay, so that means 1 is 141. So we're going to put that right there. Okay, now let's look at, do y'all see the triangle I see? Do y'all see this triangle right here? Because we have 2 angles in that triangle, can't we find the third? So couldn't we find the angle 7 by doing 180 minus the 39 and minus the 53? So that means for angle 7, we would get 88 degrees, right? So that means this is 88, which means 5 is 88, right? Okay, so angle 5 is 88 because they're vertical angles, right? And then what would 6 be? How would we find that? Do you notice this straight line right here? Okay, so couldn't we go 180 minus the 88 right here? to find that angle? Indeed. So this angle is going to be 92, isn't it? Okay. So over here on the other side, same thing right here, right? So couldn't we find angle 11 by doing 180 minus the 53? So 180 minus 53 is 127. So angle 11 is equal to 127, which means angle 9 is 127. Y'all see that because it's a vertical angle. So that's 127 degrees. Okay, then if we move down here to 15, notice again we got a straight line, right? So can't we find 15 by subtracting 92 from 15? Indeed, so that would be 88 degrees, right? So if this is 88, its vertical angle down here is 88, right? Okay, so what are we going to do over here where we have 18, 19, 17, 18, 19, 20, okay? So we have a relationship over here that hopefully all of y'all can see. We have that angle should be congruent with that angle because they're corresponding angles, right? So because we have parallel lines, they're on the same side. So that means this is 53 degrees, which means 18 has to be 53, right? Which also means this has got to be 127 because it's a linear pair and they have to add up to be 180. And that means that also is 127. So 17 is 127 and 20 was 53. Okay, so now it says tell what relationships exist between the angles. So we're going to use our drawing. So 9 and 18. So let's look at 9 and 18. That's this pair right here. 9, where the heck is 9? Oh, I got it covered up. I can't see it. I think it's right there, y'all. Yeah. 9 and 18. What is that relationship right there? Are they on alternate or same sides of the transversal? Same side, right? So same side and inside the parallel lines, right? So same side interior was D, right? And it also says to then put the symbol congruent or 180. So this is 180 degrees, right? They're not the same shape, so we know they can't be the same measure. So then let's look at 7 and 15. 7 is here, 15 is there. Those are on the same side of the parallel lines and the same side of the transversal. So these are going to be corresponding angles. So that's A. And look, hopefully you can tell they have the same angle, right? So this is going to be congruent. Wow, can't write today. This is congruent, okay? And then 3 and 4. 3 and 4 up here, they form a line, don't they? So that's a linear pair. So that's G, and again, they don't look like they're the same shape, so they got to be 180 degrees, right? If they look like they're the same shape, then they're going to be congruent. Then we got 5 and 15. So let me see if I can pull a different color, y'all, so we can pull this out a little better. I'll use orange. Okay, 5 is here, and 15 is there. They're definitely alternate. Are they inside or outside the parallel lines? So alternate interior angles, right? So this one is B, and again, they are congruent because they look the same shape, don't they? Then let's talk about 13 and 7. So here's 7 right there, and there's 13, okay? So those are also alternate angles, right? So they're not on the same side of the transversal. Are they inside or outside the parallel line? So yeah, that's alternate exterior angles. So this is C. Do they look like they are the same shape? They are also parallel. And then we've got 11 and 20. 11 and 20. Okay, so you notice one of those is obtuse and one's acute. So we know it's going to be supplementary, right? They're going to be 180 degrees. So what is that relationship, though? Same side exterior. You got it. So this is going to be 180. All right, then we got 2 and 4. So up here we've got angle 2 and angle 4 right there. Angle 2 and 4 at the top up there. Angles 2 and 4 are vertical angles, aren't they? So that's F. And again, vertical angles are congruent, aren't they? Exactly. Okay. Then it says state what theorems are used to find the missing angles and find the missing angles, right? So we're going to find the missing angles. So you should notice that these sides are congruent. That means these angles are congruent, right? So that means this has to be 40. 40 plus 40 is 80. And so we're going to find this angle by doing 180 minus 80. And that's 100 degrees. So the measure of angle A was 100 degrees. The measure of angle B was 40. The next one says find x and the three angles. So once again, we know that these two angles down here are congruent, and we know that all the angles added up together have to equal 180, right? So what we can do is we can do 180 is equal to the 2x minus 4 plus 2 times our 3x minus 4, right? So this is going to be 180 equals 2x minus 4 plus 6x minus 8. I'm going to distribute that 2, okay? So that's going to be 180 equals, we're going to combine our like terms, our 2x and our 6x, that's going to be 8x. Negative 4 combined with the negative 8 is going to be minus 12. So now we're going to add 12 to both sides. That's going to be 192 is equal to 8x. Divide both sides by 8. And when we do that, we get 24. So x is equal to 24. So that's my x, but now I got to plug it back in, right? So when I plug it into up here, 2 times 24, that's 48 minus 4 is 44, right? So that's 44 degrees for this angle up here, which we didn't ever label. A, B, and C. There we go. So that was angle B, okay? And then we are going to find the other two angles, which will be the same. A and C will be the same, right? So we're going to go 3 times 24. That's 72, and 72 minus 4 is equal to 68 degrees, right? Now you can check this by adding 68 plus 44 and seeing if all three of those add up to be 180 degrees, okay? This next one says solve for the value of x in the problem, state which theorems. Oh, by the way, these are the angle addition, or the angle sum, angle sum theorems that are used here. When we add three angles together, they equal 180. That's the angle sum theorem, okay? Number 11 says solve for the value of x and state what theorems are used. This one, again, is going to be angle sum. But here's what we notice. If we've got three congruent sides, it means we have three congruent angles, right? So we could take 180 divided by 3. That means it's going to be 60. And that should be equal to our 2x, right? So that means x is going to be equal to 30 because 60 divided by 2 is 30. Okay? This next one, this is what we call the third angles theorem. Okay? So we're going to write third angles theorem. Okay, and the reason that is because we have two angles and we want to find the third. Okay, so notice we have that N is 2 arcs and R would be 2 arcs, so this is also 55 up here. We have that L has 1 arc, and so S has 1 arc, so that would be 65. So then to find X here, what we would do, so we know now R and S, right? We know those angles. So then how would we find the measure of angle M? Because we could do this one of two ways, but let's find the measure of angle M. So we're going to add the 55 plus the 65. So when we add the 55 to the 65, that gives us, what is that, 120? Okay, so that if that's 120 and we subtract that from 180, that means angle M has got to be 60 degrees, right? So that if angle M is 60 degrees up here, then can't we set that equal to the measure of angle T? So we could say 60 equals 2x plus 30, subtract 30 from both sides, so 30 equals 2x, and divide both sides by 2, so x equals 15. And we know, again, that this is a 60-degree angle because it's got to be congruent with T, right? I mean with M. My bad. So then it says find the measure of angle BCA. So this is what we call the exterior angles theorem. Okay. Now we're not only going to use that, but we're going to use some linear pairs, right? So here's the deal. So if this inside angle, we know that this angle plus this angle plus this angle has to equal 180, right? So if that's true, then the angles outside of there, the two angles outside of there, are going to have to add up to be 60. And let me show you why. This angle, well, let me do it in red. This angle plus, notice that's the other side of that angle, plus that angle, plus this angle right here, don't they equal a whole circle? They do, okay? Because we've got alternate sides. So that means when I add those three angles together, they have to equal 360, okay? So we're going to just add those together, 9x plus 1 plus 5x plus 12 plus 10x minus 37. When we do that, we get 360 equals 9x and 5x and 10x are going to be, what is that, 19, so that's going to be 14x. No, wait, my bad. I can't add today. So this was 24x, right? 24x. And then 37 from 13 is also 24. But that's minus 24. Whoa, wait a minute. Minus 24. So then we're going to add, well, 24x minus 24. We're going to add 24 to both sides, so that's going to give us 384 equals 24x. We're going to divide both sides by our 24. So x is going to be equal to 16. So it's actually asking us to find the measure of angle BCA. So BCA is this angle right here. So we need to find the exterior angle to find the interior angle, okay? So what we're going to do is we're going to do 10 times our 16. That's 160 minus 37. So when I did that, I got 123. Now, if this angle out here is 123, how would we find the angle next to it that forms the line? We would subtract 180 minus 123, and that's equal to 57 degrees, okay? Now, remember that these two angles, if we had to find the other angles, we could do so. Remember this angle, this angle plus that angle, the remote interior angles equal this exterior angle, okay? So we could find those as well if we were given one of them, okay? Important that you guys can do all that. All right, so this next one says, gives us the statements and reasons and tells us to finish the proof. So FG is equal to DG. Where did this piece of information come from? It's right there. It was given to us, right? Now we're going to mark it in the drawing. FG is congruent to DG. Then it says G is the midpoint of EC. Well, if G is the midpoint of EC, then isn't EG congruent with CG? Indeed. So this piece of information was also given to us, right? And then it says definition of a midpoint. So what did we just mark in the drawing? We said EG was congruent with CG, right? I'm going to go up here. That's up here, EG, CG, right? We have a given and another given. Okay, then it says angle EGF. EGF, so it's talking about this angle, is congruent with DGC, that angle. So why are those angles congruent? Because they're vertical angles, right? They're vertical angles. So this is the vertical angles congruence theorem. So I'm just going to write vertical angles congruence, okay? All right, then we've got a triangle statement. Y'all see this side angle side. So that means we should have a statement. So let's go ahead and mark through that vertical angles congruence. And then we're looking for a triangle statement. So it says EGF. EGF is congruent with D. No, can't start with D, can we? If we started with E over here, it's at the end of the 2-tick side. We can't start with the 1-tick, the end of the 1-tick side. So this definitely can't be an answer, right? Let's try the other one, FGE. So this time we're going F, 1-tick side, G to the congruent angle to the 2, FGE, right? And then over here, so let's go across the 1-tick. So that would be D, G. It should be C, y'all. Yeah, there should be a C up there, so it wasn't right. But we'll fix it. So this is going to be triangle F, G, E is congruent with triangle D, G, C. Okay, so now we got that one. And that was side angle side. And then why could we say that that a part of the triangles is not currently marked as congruent? Because of corresponding parts of congruent triangles are congruent. So that means we can say an additional part. So here's the deal. If you prove that two triangles are congruent, then you can say any of their parts are congruent. Any angles, any sides. That's what CP/CTC communicates, okay? So now this one is our triangle sum theorem, okay? So we've done this innumerable times last semester. So angles of a straight angle, okay? So it says that we're given the triangle, and then we constructed this line. Y'all see this line? Isn't that a straight angle? So what are the three angles that make up that angle? So, and I'm just going to do them in order. The measure of angle 4 plus the measure of angle 2. Y'all see this? 4, 2, 5. Plus the measure of angle 5 equals 180, right? Okay. Then it says that the measure of angle 1 is congruent to the measure of angle 4. Measure of angle 1 is congruent to the measure of angle 4. These are parallel, guys. So if those are parallel, it says that construct an auxiliary line parallel to AC through B, okay? So it's parallel, so that means that angle 1 and 4 are congruent. Why? Because they're alternate interior angles, aren't they? So again, it's the alternate interior angles theorem. So is there another pair of alternate interior angles in this drawing? Indeed, I see them as well. So this angle 5 is congruent with angle 3, isn't it? So the measure of angle 5 is equal to the measure of angle 3. Then, why could we make the last statement? So I want you to notice, look at 1 and 4. Look at step 3. Y'all see step 3 right here? So it says 1 and 4. So 4 is right there and 1 is right there. So didn't you substitute that in? Then the next step is 5, right? So 5 and 3. Y'all see that? See here? 5 and 3 are congruent. So we substituted that. So this is the substitution property. Okay? All right. So this next one says state on the line below why each of the triangles are congruent. Remember to mark the additional information you know, like shared sides and congruent angles. So here we can mark these angles because they're vertical angles, right? So what do we have? A side, an angle, and a side. A side, an angle, and a side. So this is side, angle, side. Okay, this next one has an angle and then a side next to a side. So we don't do but or but backwards, right? So these are not congruent because we don't use ASS. All right, we can mark the shared side here. So what do we have? An angle, a side, and an angle, a side, and an angle, right? So this is angle, side, angle. All right, this next one, what do we have? Notice we have an angle, and a side. Angle, angle, side. Don't assume it's HL just because there's a right angle, okay? Here we have a common shared side again, right? So what do we have? Side, side, side. Okay. So here's our last one. We have a shared side again, and that's our hypotenuse, isn't it? Because it's opposite our right angle, and then we have another leg, right? So this is HL. Remember, with HL, you have to have a right triangle, and you have to have the hypotenuse in one other leg. So 17 says, what can you mark on the triangle to show congruent sides or angles? Okay, so on this one, this is probably one of the harder ones. Okay, so first, most of you probably noticed that we have vertical angles, right? So we could say that angle ACB is congruent with angle ECD because they're vertical angles, right? Then we could also say that this angle, angle A, is congruent with angle E because they're alternate interior angles. Y'all see these parallel lines right here? And then a transversal right here. Y'all see that transversal right there? Sorry, I can't draw a straight line today, but you guys get the drift. So those are alternate interior angles. So we could say angle A is congruent with angle E. Now we could say it again with another one, but we're not going to. So this is alternate interior angles, right? Okay. So then it says state your reason for the congruence. Well, I did that above. So it says if you wanted to prove the triangles are congruent by angle, angle, side, what congruent statements would you use? The two we just did, right? So if you wanted to prove the triangle is congruent by angle side angle, we would need a different angle, right? So this time we could also say B, couldn't we? Because there's another transversal is congruent to D. So this time we would say angle B. Yeah, it'd be great if I could draw. Is congruent with angle D. And that would be, again, because they're alternate interior angles to each other, right? All right, then it says complete the triangle congruent statement. Okay, so this time, oh, I should have put 3 arcs here, go. My bad. Okay, triangle A, B, C, we got 2 arcs, 3 arcs, and 1. So what is 2 arcs on the one? So this would be E, right? And then I went to 3, so that would be D, and then C. Okay? This one says, what can you mark on the triangle to show congruent sides or angles? State your reason for the congruence, okay? So on this one, I want to show you, it shows us that there's a side congruent, and we got the shared side, right? So that would be what we would state. Okay, then notice that we have, again, parallel sides, and our diagonal is going to be our transversal, right? So then we have those angles. So what do you notice? Side, angle, side, right? Do you guys notice that? So it says if you wanted the triangles to be congruent by side, side, side. So this would be side, angle, side. So we would have used the 1 tick sides here, and then we would have used the angle up here. So let's just say angle WXZ is congruent with YZX, angle YZX, because they're alternate interior angles again, right? And what would we say about that shared side? Would we go across that shared side the same direction? Wouldn't we say XZ is congruent to ZX? And what do we call that when we don't go across the side the same way? Don't we call that the symmetric property? So I'm just trying to bring back to your memory all the things you guys might need, okay? Then it says what if you wanted to prove that they were congruent by side, 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 what additional piece of information would you need? We'd need these 2 opposite sides, wouldn't we? So we would need that WZ is congruent with YX, okay? Then it says complete the triangle congruent statement again. WXZ, so we went across the 1 tick side from the corner, so it's going to have to be YZX over here. All right, here's our last one like this. Complete the triangle congruent. Oh, so what can you mark in the triangles? So there's 2 things we can mark in this one, the shared side and that other right angle over there, right? So it says, what can you mark in the triangles? So that's the 2 things that we could mark. If you wanted to prove the triangle's congruent by side, angle, side, what congruent statements would you use? So you would use ST is congruent with QT. Angle STR, this angle right here, that one, is congruent with QTR. And then you would say our side RT is congruent to side RT. And then it said, if you wanted to prove the triangle is congruent by HL, what additional information would you need? We would have to have that our hypotenuses are congruent, right? That's the only way that we could prove that these are congruent by HL. So then it says, complete the congruent statement RST. So RST is going across my 3 tick side. So I'm going to go RQT, right? All right, it says, if a shape has been dilated, what happens to the angles in the side? Well, with angles, angles don't dilate, okay? They don't change. The angles will not change. So don't change. That's what's true of angles when you dilate a shape. They don't change, okay? However, the sides are proportional. So that means if they got bigger, it would be a scale factor that's greater than 1. If they got smaller, it'd be a scale factor that's less than 1. So 21 says, what 2 rigid motions map triangle ABC to DEF? Okay, so I think AB maps to DE. So I'm going to put a tick, a mark, and a mark. Okay, so everybody should be able to see that turned, right? So if we just turned this shape, how much would we turn it? So if we're talking about this one, remember, rotations go this way, okay? So how far did it rotate? I would say 270 degrees, right? 270-degree rotation. Now here's the question. If it rotated A, or actually it could be also a 90-degree clockwise, right? Okay, so if we're looking at A is D, right? So A becomes D. So something else happened, right? So because if we rotated A and it is 1, 3, and now D is 7, -1, we didn't just change the numbers, did we? I mean, the name, something more happened. So if we just rotate this, it becomes 3, -1, doesn't it? Okay. So if it becomes 3, -1, it would be right there. So that would be my A prime. So what else happened? It moved to the right as well, didn't it? 1, 2, 3, 4. So it didn't move down any, so that's good. So it's a 270-degree rotation and right 4. Okay, that's what happened. So then what happened to B? Pretty clearly looks like it flipped, didn't it? Over the what? The x-axis. So I would say it's a reflection over the x-axis. But again, if it just reflected it, wouldn't it have ended up here? Right there. Wouldn't that be my shape if it just reflected? That would be B and C and A, right? So something else happened to it. What else happened to it? So notice this side is 1 and this side is 3, right? This side is 2 and this side is 6. So what happened to it? It also dilated by a factor of 3. Now if it got smaller, it's going to be a number under 1, right? This is 3 because it got bigger. Okay. All right, we got one left. No? Oh, sorry, we've got several left. Okay, so first I want to tell y'all that this statement up here is not right. I played with this problem for a long time because I knew there was something wrong with it. So that should be VXW. So this should be triangle VXW. So we're going to mark these sides ST. And I'm just going to, let's just start with SU. So SU's first last. So SU's first last, that's our smallest side. So that would be VX. VX. So SU maps to what? VW. VW, this side. So we're going to put one mark on that side, okay? Then if we look at our second side, which is 12, so we're going to put 2 on this one. And ST are the first 2 letters. So over here it would be VX. VX, so this would be 2 dots, okay? And then our last side is UT or TU, which would be our 2 last letters. So that would be XW, right? So we're going to go 3 here. Now this is important because we can't set up this ratio if we don't do this, okay? So it's a little tricky. Okay, so let's take, we're going to solve for VW. So we've got one tick. So let's say our 8 here over our VW is equal to, and now it doesn't matter what we use. So we could do the 12, which is the ST, two dots over our 2 dots, right? So now we cross multiply these to solve it, right? So that's 12 VW is equal to 48. Divide both sides by 12, so VW is equal to 4. So this one's tricky, guys, okay? And it was not set up right originally because the actual similarity statement was wrong. Okay, so the next one says that AD is parallel with BC. This is important because if these are parallel, then we can use this. We can put a part over a part, right? So we can put the 3 over the 4x plus 1. And that's equal to the 4 over the 6x. Y'all see that green line I drew? Now we just cross multiply. So that's going to be 4 times 4x plus 1. And that's equal to 3 times 6x. So that's going to be 16x plus 4 equals 18x. Subtract the 16x from both sides. So 4 is equal to 2x. So x is equal to 2. Then it tells us to plug that back in. So for EA, That's going to be 4 times 2, which plus 1, which is 9. And then for ED, that's going to be 6 times 2, which is equal to 12. Now, the way we check this is we put these over one another, see if we get the same fraction. So for this part right here, it would be 9 and 3, right? So 9 divided by 3 is 3, right? So for this part down here, we said it was 12. And 12 divided by 4 is also 3. Okay, so that's the way we check the problem. All right, this next one says here, determine if similar, if so, why, and write a triangle similarity statement. So we do know that there's vertical angles here, so we're going to mark them first. Then we're going to talk about short side and longer side and longer side. So we're going to set up the short over the short, 27 over 18. 9 goes into both of those, so that's 3 over 2. We're going to compare that with our 36 over our 24. 12 goes into both of those, so this is also 3 over 2. So we can say that these are similar, right? Because we get the same ratio for both sides. Remember, angles are congruent. So we're going to say triangle ABE is similar to triangle. Went across the one tick side, so we got to go across the one tick side on the other one. So that's going to be DBC. Why are they similar? By side, angle, side similarity, right? Because we compared a side to a side and then angles in the middle. All right, so this next one, it says find the height. So it's asking us to find the height of the tree. That's this right here. And it says that the flag is 12 meters, okay? So what we're going to do is, to find this, we got to look at little triangle and big triangle, okay? That's what we're going to compare. So let's talk about the height of the flagpole over the height of the tree, okay? That's going to be equal to this part down here, which is, I don't know, the base, you call the base. But then we need the whole base, don't we? So we got to add the 18 and the 8. So that's going to be 26 meters, okay? So that's got to be over 26. So again, I need you guys to see little triangle. We got a little triangle over here. Can you guys see this little triangle right here? And then we have a big triangle right here. So we want to talk little triangle, big triangle. Y'all got me? That's the ratio we want to set up. Okay, so we're going to do 8h is equal to 12 times 26. When I multiply 12 times 26, I get 312. And then divide 8 into 312, and that's going to give me 39 feet. So my tree is 39 feet tall. Okay, so this last one is the triangle proportionality theorem. We're going to work through this. DE is congruent to BC. That was given. And yeah, we got that. Then it asks us, it tells us ADE, angle ADE is congruent with angle B. Yep, those angles are congruent. Why? Because they're corresponding angles, right? So that's going to be D, corresponding angles. All right, then it says angle similarity. That tells me that I'm going to have a triangle statement. And we only have one of those. Y'all see that right there? So that's going to be G. So that's going to be triangle ABC is similar to triangle ADE. Then it says corresponding sides of a triangle of similar triangles are proportional. So that's got to be talking about it's talking about sides, right? So we got two triangles. We've got this triangle here, and then we've got this triangle here. Y'all see that? So wouldn't that be AB, the whole side, over AD? That's what this is. Y'all see it right there? So that's what we're going to have. So this is going to be E. So that's going to be AB over AD is equal to AC over AE. Then the next statement we're looking for a reason for. Okay, so the next statement says AD plus AB, AD plus DB. Oh, that's the segment addition postulate, isn't it, y'all? It is. Okay, so we're going to mark out that one. Because a part times a part equals the whole, right? Then it says the substitution properties from steps 4 and 5, okay? So if we look at steps 4 and 5, AB over AD. So what is AB equal to now? It's AD and DB, right? So that's got to be H right here. Y'all see that? So we're going to write that AD plus DB is over AD, right? And that's going to be equal to our AE, talking about this right here, plus EC over our AE, right? Okay. So that was this step. I'm circling stuff as I use it. That was substitution property. Now, what do you notice now? Do you notice this right here? Can you guys see this? AD over AD, that's that right there. AE over AE, that's right there. So what did they just do? They separated the fractions, didn't they? So that was A. Okay. And then what is this equal to right here? Anything over itself. Isn't that going to be our 1 plus DB over AD? Oh, you know what? I never wrote that letter for number 6, did I? That was H. Sorry, let me go back up here. Right, H? Okay. So this one's going to be F, yes? It's the only thing that's left, too, by the way, y'all. And that's going to be equal to, again, our 1 plus our EC over our AE. That's simplifying. And then, what was subtracted from both sides to get to the bottom? What's the same on both sides? 1, right, y'all? So that's the subtraction property for the last one. So this is B, okay? Because they basically just subtracted 1 from both sides. So that's it.